Greetings, Internet. This is Nick, or Arrow from Not Robot, and I am here with my fellow game creators, Derek and Ryan, also from Not Robot, and we're going to give you a quick walkthrough of our prototype of our game, Wave Crash. Do you guys want to go ahead and introduce yourselves?
I'm Derek, and you may end up hearing me called Dino on here.
I am Ryan, and I may be called Viking at some times.
Cool. So as I mentioned before, we are going to kind of give a quick walkthrough of our prototype for Wave Crash. We're going to talk about some of the decisions we made, some of the tech we used, and kind of just why we did the things we did in general. So why Wave Crash? First off, we wanted to make sure we could do a game and we could figure out kind of the big problems and find the solutions to them. So we wanted to start with a really small scope project. So we decided on a project that we could manage with 10 hours per person per week. So something we could easily do without being too straining on our time. We wanted a game that we thought we could do in only a couple months, which we kind of failed on that one a little bit, but we'll talk about that later. We also wanted to make a game that we thought we could do easily, but it would still be a lot of fun. So we decided on a runner type game, but we wanted to put our own twist to it, which is kind of why we have this really physics-intense runner that you have in front of you now. Yeah, so we just wanted to make something easy, simple, quick, that would still be fun, and that's why we decided on Wave Crash.
Basically, there were a lot of things that we needed to learn how to do, as a company and within the game itself. So we needed to learn to work as a team, and we needed to grow our team and kind of become a well-oiled machine in that respect. And we also didn't want to dive into anything that was a particularly huge problem or was a daunting task to try and figure out, well, how do we write an algorithm that does this or things like that. So we thought it would be best to try and solve, small problems first and a constrained scope, and then in future titles move on to bigger and better things. So again, we just kind of wanted to focus on something that would be more simple and that we could do super well instead of trying to do a lot of different things and kind of half-ass them. Right, yes, so we wanted to do something, limited in scope, a very constrained gameplay loop without a lot of variables so that we could both iterate on it quickly, get it refined and working gameplay-wise, but also technically, and not have too many huge challenges there.
This is our first project, mainly for the three of us, that's been a side project that we are actually taking all the way from initial conception to market. And so, like Nick said, and Ryan said, we wanted to constrain the scope and keep this small. And so we kind of consider this the first step that we're going to take of many. And we have really big dreams for the kind of games we want to create. But this is where we're starting to make sure that we complete it and keep working towards that. And another important thing to us with the game is we ran in the past sometimes into problems where we would dive too deep into a problem and lose sight of having a fun game to play. At least Ryan and I did in our side projects in the past. And so we wanted to make sure that we got to a prototype that was fun. We had fun playing it, even as we develop it and add features and make it better. And one of the main problems that we've had is that we waste a lot of time playing our game when we're just trying to test for features.
Yeah, I think we're all a little guilty of that one. Behind you, we are hopefully showing the video to our prototype. I'm not sure if you guys have been following along with our other content, but you've probably seen pictures of what the game looks like now. So you know that the prototype is super basic compared to what we have now. But it's still extremely important to recognize that, we made that prototype that basic on purpose. We just wanted to, kind of get an outlet to test our basic ideals, our basic mechanics, to make sure that what we were doing is actually something that would end up fun in the end. If you have something that's not fun and you add a bunch more features to it, chances are it's still not going to be fun. So in the video, you have, the really basic game. You have the entire control scheme, the forward and backward button. You have the little vehicle dude that's running around that you drive, and you have him spinning through the air. And then, really importantly, you have kind of randomly generated maps, which we thought would be really fun to have in the game. Kind of a dynamic map, which will allow us to generate a lot more content on the fly, while at the same time just give a feeling to players that there's just a lot more content because it's different every time.
I just kind of want to hit the topic of how basic your prototype needs to be. a lot of people will approach something and they'll think, well, what do I need to make this function? And they'll think about all, end concept type things, final art assets, final gameplay, these types of things. And it's really, I mean, it's good that you think about those things, but if you don't actually play it, you don't know that that vision or concept of what you have in your mind of the game is actually going to be fun. Getting the prototype out there as fast as possible is very important, and it needs to be in its rawest, most simple form, and just build it as fast as you can. Get it to a playable state as quickly as possible.
I think it's important to point out the small nuances that you're seeing on the screen right now, and how much time was poured into getting the graphics to be exactly how they are. I think you're going to notice that the the stick with wheels is it's 50 pixels long. It's not 49. It's not 51. And we did a lot of A/B testing to determine how long it should be.
Similarly, the orange we picked for our maps is a very specific orange. We tested thousands of red, green, blue combinations on our horde of unwilling subjects to make sure we maximize the fun potential of our game. We want to make sure we maximize that fun. That's why we started with blue ways, but after a lot of testing, we realized that orange is just better. As Ryan mentioned, for our prototype, we wanted the vehicle, which was the player actor. We wanted the maps, which is what the vehicle is riding on. And we wanted the vehicle moving really, really fast, which you can see it's kind of ridiculous in this iteration. You can't really tell where you're going, and you just fly through the air. And we wanted it orange, because orange is good. Alright, so next we're going to talk about some of our basic coding decisions that went along in the background that you might not be seeing just from the video. So I'm going to start off giving it to Dino, or Derek here. He's going to tell you a bit about our framework.
So there's a couple different things that you probably need to consider when you're looking for a framework to work within. And the most basic of them is that your framework should lower the amount of work that you need to do in order to get to market. And so we did some research at the beginning on different things that were out there and available. And like I mentioned at the start, this is the first project that we've taken from beginning to market. And so we wanted to make sure that we pick a framework that will keep us productive from beginning to end and not tie our hands at the end when we're trying to do cool stuff. And we also want to, like I mentioned, this is kind of the first step in doing more and more. And so we want something that will grow with us, that we can build on the code base that we develop. So there's a couple different options. Like we had mentioned before, our target market is iOS, but if possible, we would like to be OS agnostic so that we could move to Android, move to the web, move wherever we want in order to grow our company. So a couple of the things that we looked at first would be Unity. Unity is just really popular right now as a cross-platform framework. And then specifically for iOS, we started looking at Sparrow, which is it's an Objective-C library, but it's kind of modeled based on the old Flash framework that a lot of people are familiar with from Flash game development. The problem with Sparrow is it's not portable, but none of us had any Objective-C coding background, and we were able to get, what we do is make Pong to test the viability of a framework, and we were able to get Pong pretty much out in like 1 or 2 weeks of work. I don't really remember quite how long, but working at 10 hours a week, you're looking at 20 hours to kind of get completely grok or get a really good idea on how good a framework is going to be. So based on using Sparrow, which we really liked it, we also saw that the same people who developed Sparrow developed Starling, and Starling has its roots in the Flash game development era. Starling is built on top of the Adobe Air platform, and the nice thing about Adobe Air is you can release pretty much everywhere. It's almost as ubiquitous as Flash gaming was. After kind of testing those things out, and based also on our constraints that we're a bootstrapped company starting from the beginning, Starling and Adobe Air work really well with us because they're free, in addition to being just a good platform to develop on. And so, as we mentioned also, we decided to tackle a game with kind of a full physics engine to differentiate us from other competitors and other people who have done runner-type games. and we just wanted to enable just a rich player experience. And so in order to do that, we obviously didn't want to write our own physics library, or well, we might want to, but it's not a good idea to. So there's kind of two options out there for the ActionScript environment that people might want to use. There's a Box2D port. Box2D is just super popular. You're always going to have a ton of support when you use it, and tons of people to answer questions. But what we found and what we saw is that it's not quite as fast as a physics library called Nape when running on ActionScript, and in a lot of cases we saw Nape required 6 times less CPU than Box2D. So for our final decision, we're writing Wavecrash in Starling using Nape as our physics library. And if you're interested, you could tie it together yourself, but at the start we decided to use Citrus Engine to tie everything together.
The greatest thing about Citrus is that it immediately allowed us to hit the ground running. I mean, we're kind of outgrowing it, I would say, but it just kind of had everything built in from the start. We didn't have to fight anything. And as you said, the role of any good framework is to kind of make it so you have to do as little work as possible. And I think where we are now, we've kind of grown beyond it. But at the beginning, when we didn't really know Starling as well as we do, we didn't know Nape as well as we do, Citrus was really great at getting us to that point.
Yeah, it's definitely true.
Cool, so that's a pretty good overview of why we made some of the big technical decisions we made. Now we're going to switch into actually talking about some of the big issues coding-wise for Wavecrash and kind of what the big problems were and how we solved them. So I think, Ryan, you probably know best about that. Why don't you start us off?
So I think the biggest issue with our prototype is the physics engine. We talked a lot, I mean, just a couple of minutes ago about kind of trying to constrain the scope of our prototype and make it as little as possible, but that full-fledged physics engine was kind of necessary for the end game, and you do kind of want your prototype to be representative of what the end game will be, so to do that without a physics engine would just kind of be an exercise in something that's worthless. So getting that into the game and getting it integrated in things was a lot easier through Citrus than it would have been without, but it still was kind of a hurdle, how to get things on screen, how to make them behave. So you have that kind of problem where you don't actually know what the right mass for any of your objects is. You don't know what the right friction or any of those types of things for the ground or any other objects in the environment are. And getting everything to kind of be congruent and balanced is always going to take a little while. And I think, I mean, both getting the physics engine in there and then kind of getting it balanced, it was one of the biggest issues that we had getting the prototype running. If we kind of faked it and made our own like homegrown solution, it would be buggy. It wouldn't be what the end game would actually be. So you would play it and you would have some expectation of what things were going to be like, and it might be fun. And then you get the real physics engine and it just plays completely differently. I mean, the biggest thing about that prototype is getting a first peek kind of at what your game is going to be and figuring out, I mean, how it's going to be fun and what ways are going to be fun. And you might even discover things that you didn't know were going to be fun that just, are fun. And you can run with those ideas and flesh them out. But if you don't actually have it representative of what the game is going to be, you're kind of going down the wrong path, and it's kind of like a dead end. You're not going to get where you want to be.
You can also ask the question when you're developing a game like, why go through all this headache that Ryan just described of tweaking the physics engine? And basically the idea is, just like he said, like you're modeling a virtual version of the real world, and what that enables is just a lot of cool, unscripted things that can happen in your game, and just reactions that just feel much more natural to people who are playing. And it gives you the kind of scope where things can happen in your game that you just can't plan for, but that make for those fun moments for players.
So next, we're going to briefly go over and talk about what we think went right in our prototype, and then what we think went wrong. So to start us off, I think we were all almost kind of surprised as soon as we got the physics in, as soon as we got the map and the vehicle in, how fun it was right off the bat. Like we had, we had our friends, good people playing it that just were laughing and giggling the entire time at just how ridiculous the prototype was, and they couldn't put it down. Something we spent minimal time on was already making people happy. So that was a huge motivating factor for us, and just meant that we were onto something right off the bat.
Yeah, I can definitely say that as soon as the physics were working with the vehicle and it was playable, I lost a large amount of time that I should have been debugging and making it work, just playing it and laughing hysterically at that little car.
We all did that. And so when you're planning for your own game, make sure that you add like 10 to 20% more time onto your schedule because you're going to be playing your game and you're going to think it's fun. And if you don't, you probably need to find a new game to develop.
Next, what do you guys think went wrong?
I think this isn't specific to the prototype, but it's kind of in that prototyping phase and the transition from prototyping to actually writing the game. I think when we got it working and we had the prototype, we didn't ever take a minute and look at what was there and then try and figure out how best to build it at an architecture level wise in the real game. We just kind of took what we had from the prototype and then started adding features and growing it organically. And I think if we had had that moment where we looked at the whole project and said, okay, here's what we have, here's where we want to be, kind of draw a map in the middle of how to get there, I think would have been better than just kind of, getting in the car and going. Certainly wasn't terrible, but things could have been better. We introduced a lot of technical debt along the way.
I think that's kind of its own discussion just because, we didn't exactly know where we were going. A lot of the path kind of changed based on what we found fun and what we found unfun as well. And so it's not always possible to plan where you're going because half the time you don't know where it is. So what you're looking at now, or were looking at before, was our prototype. So after we finished this, our next goal was to move to an alpha. Our alpha wanted to be something that kind of built some of the more basic features in to kind of give more of a representation of what the game was going to be. And then we also wanted just at least some low-level art to meet the theme so that people could tell what the player was and what was actually going on, kind of get some narrative going. So those were our two big things that we wanted to push on next after we finished the prototype as far as design goes. Design issues moving forward, we needed to make sure that everything we added was something that would make the game more fun. We don't ever want to add a feature that makes it less fun. In fact, there was a time where we kind of, the very first vehicle in the game was kind of almost too underpowered. So the game was a lot of fun to play as a jet ski, but if you're playing as the wakeboard, it just wasn't fun. So you can't have that first vehicle be not fun. You need to have the first vehicle be a blast, and then the next vehicle be a bigger blast. So that's kind of one of the big design issues that was a little difficult, is that you had to progress them from fun to more fun. But if you don't catch them in the 30 seconds, you're never going to keep those players.
And so moving forward from the prototype that you're looking at, we definitely want to add more cosmetics, get everything looking good, add more maps, and just in general, hopefully we find some more things that make the game fun and differentiate us. So that just about wraps up what we wanted to talk about our prototype. Hopefully you learned something about what you should look for when you're developing your game and making a prototype. And the things to keep in mind are just keep it fun, make sure your game is always fun, make sure you keep your scope limited, get to that prototype as fast as possible like Ryan was talking about.
Yeah, so hopefully you found something of value. If there's something you hope we touch on in future blog posts or video blogs, make sure you leave us a comment and we'll give you whatever you think can be valuable.
Yeah, we basically want to be just like 100% open about everything we're working on, and we figure if we help each other out, it makes us all better.
So look forward to hearing your responses, hearing your ideas, whether or not they mimic ours, in the comments.
And it's also important to keep in mind that none of the three of us are robots.
We're not robots. We're not being controlled by robots. There's no robot here.
Definitely not robots. And thanks for watching.